Karl Groves. I'm the founder and president of Tenon.io. We're going to talk about some of the large-scale data gathering that we are doing at Tenon to uncover possible patterns and correlations and relationships in the data between automatic and manual testing. So we see here on this slide a couple of bits of data that we have already. We're going to talk about the sources of the data. So on the left column, we have a description of the data from Tenon itself. Now, this isn't meant to be a product sales pitch. The fact is just that Tenon gathers all this data. We can analyze it and get information from it. But we have about 10,000 users worldwide. Actually, that slide's probably out of date. It's about 11,000 now. It's in use 24/7, 365 in 477 cities in 61 countries on every continent. Yes, every continent. So I saw in the analytics, somebody's testing stuff for accessibility in Antarctica. I guess if you got nothing else to do, you could do accessibility testing. I don't know. Anyway, we've already analyzed over 6 million URLs across 470,000 unique domains. As part of this process, for users who allow us to collect anonymous statistics, we have another process behind the scenes that runs 24/7, 365. And also, we also just pipe in the Alexa top 1 million into this on an ongoing process as well. And so we've logged over 14,600,000 errors. Now, some of this other data that the research product is testing is things like the types of errors, the numbers of errors, the density of pages. Density is a unique metric that we check that is related to the number of errors in correlation with the size of the page, and then the test passing versus failing. Some of the other site data that we gather just to see if we can glean any information from that would be like the domain, the company who owns the site, not the company name, but information about the company like the market vertical, the country or region that they're from. We also gather information on the technologies in use, and then their Alexa and Quantcast data. So I updated this slide this morning with the latest information. So as part of this data gathering, we've gathered information on 11,109 total different types of technologies in 204 technology categories. So those categories would be things like whether it's a e-commerce platform, whether it's an advertising platform, whether it's a specific type of content management system, whether it's anything like that. And so some of those categories are completely irrelevant, and we don't irrelevant for accessibility rather, because we also get categories on information like what backend technology is used. And so backend, generally speaking, doesn't have any impact on the front end accessibility, depending on, of course, the platform and whether they tie together business logic with presentation logic. But anyway, total vertical markets that we've gathered the data on is 25. Now, of the things on this slide, the two most important ones actually are the last two, the average Alexa rank and the average Quantcast rank of the sites that we've tested. Average Alexa rank, for instance, is 47,442, and the Quantcast rank 51,350. And so what this means is that from the data that we're gathering, these are very popular websites, okay? And so our assumption is should have been built by professional developers rather than hobbyists, because we know, for instance, hobbyists are going to make more accessibility errors usually than somebody who's a professional developer. That's not always the case, but that's going to be our assumption. In other words, we should expect a professional developer to make fewer mistakes than amateur. This slide here talks about the issues by content type. So this is where we're starting to break down the type of issues that we've gathered from testing. Now, this is automatically generated data. This is from automated testing and not manual. We're going to take a look at manual in a minute. So 90% The automatically discoverable issues reside in the following content types: images and non-text content, navigation, language typography and content, custom controls, and document structure. And you can see here on this bar chart, we're talking really about 70% of the issues relating to images and non-text content and navigation. Now, this is not the severity of the issues, this is merely the volume. Here's another chart. This is the issues by WCAG level. The WCAG, in case you're not aware of what it is, it's the Web Content Accessibility Guidelines. It's broken down into 3 levels of conformance. I could do an entire talk on what those differences mean between the levels, but the interesting thing here is that 64.6% of the automatically discovered errors are WCAG level A. WCAG level A is the obvious, as the name would imply, the first layer of conformance. These are the things that really need to be conformant with, and as we can see here, 64.6% of the issues that we've logged are all level A issues. Double A, 14.7%, and 4.7% for the level AAA. Now, the Web Content Accessibility Guidelines are organized in a very interesting manner. They have organized around principles. And so the principles are perceivable, operable, understandable, and robust. And so this chart shows 45% of the issues that have been automatically logged are issues relating to perceivability. That's going to mean that people who are blind, low vision, hard of hearing, deaf, and colorblind are going to be impacted by these issues pretty significantly. Operable relates to things like keyboard accessibility, device independence, things like that. That's 21.4%. Understandable is relating to the organization of the content, the relationships between different types of content. That's 9.7, and the robust is 7.9. And that relates, a lot of the robustness stuff relates to whether we're using the right kind of markup for the purpose, the semantic markup, or are we conveying the proper relationships and labels with ARIA and things like that. So going through here, this information gets pretty interesting. I updated this slide today as well with the latest data. Average issues per page, 260. In other words, across all of the 6 million URLs that we've tested, the average issues per page is 260. There's a little bit of a difference with the way Tenon does things. Our tests are extremely granular. So in other words, if a table doesn't have any scope attributes, any relationships between the data cells and the headers for the table, and let's say there's 10 columns, that's going to give you 10 errors. So that's why those issues are much higher than you're probably aware of when you've used other tools. They might say that the table is bad, which is totally fine. It's just that our tests are in a granular way. The average density per page is 47%. So remember, I was talking about the relationship between the number of issues and the size of the page. The density actually normalizes the data a bit, and so 47% issue density. What that means is that half of the page is bad. 47% of the page is bad. Average tests failing per page is 27, which is really interesting because of something I'll mention in a moment, which is that this is a small subset. This is about 10% of our tests. 27 failing tests per page is kind of interesting, except for we have 260 tests. So that's really interesting. We'll talk about that in a minute. Average WCAG level A issues per page, 276. And then the percentage of pages out of those 6 million that we've seen so far that have 0 errors is 0.03%. But we know automation isn't enough, right? You'll see this, you'll even see this on my own blog where I say automatic testing isn't enough. Accessibility experts all over the place say automatic testing isn't enough. And obviously it seems sensible. There are things that an automatic testing tool cannot find. And for instance, on my own blog, I have this table where I've gone through and sort of determined out of all the WCAG success criteria, how can we test it? In other words, let's say there's a test. We can perform a test and we can be 100% certain that something is wrong. Something like an alt attribute for an image. If there's no alt attribute or no other mechanism providing a text alternative, we can be 100% sure of that. Then there's other stuff, and we'll use the same example of an alt attribute where there is an alt attribute supplied, but it seems kind of stinky, right? It's either really, really long, or it says includes words like irrelevant words like picture of something, you know what I mean? And so that would be a semi-automatic test, or there's different terms for that, but it would be something that has a verification component that a human needed to go through and actually verify that the test was correct. And then there's things that are manual only, things that cannot be done by a machine and require a human. Things like focus management, right? Does focus go to the right spot as a user interacts with something? Like if a dialogue is opened and the user closes the dialogue, where does the focus go after that? That's something a tool really can't do unless you're going to custom write your own functional test, which is totally doable. But an automatic tool like Tenon can't do that stuff. So we see here, this table has the WCAG level and whether and the percentage of which things can be automatic, semi-automatic, or manual. And we can see here that on WCAG level A, only 25% of the WCAG level A success criteria can be tested for with automatic testing alone. 46%, almost half of the WCAG level A success criteria have to be tested for manually in order to determine whether we're conformant or not. So this is where we're going to talk about manual testing. Now, my company Tenon also does manual testing. We do accessibility audits. Generally speaking, we're going to take a user interface from a customer's website and carve it up into what we call components, right? So let's say you have a global navigation across the top. We only need to test that once because we know it's only in the code once. It's in a template or some sort of actual component with React or something like that. We're going to carve this UI up into distinct components, and then we're going to test those. So an average number of components that we test in an audit is 23. The average total issues per audit is 139. The average issues per component is 6. They're probably going to wonder, like, why less issues per component than issues per page from the automatic testing tool? That's typically because our audits aren't as granular, right? In our audits, we're going to say your table's messed up, right? And then we'll tell the customer the exact ways that the table's messed up. So that's why there's few issues per component. So we took apart all the data from all the audits that we've ever done, and we've plugged them into Excel and grabbed these charts. And we can see here, similar to the automatic testing results, what are the issues by component type, or I'm sorry, content type. And we can see here that there's a lot more of these lower things, the frames and tables and stuff, than were in the other. It's kind of more evenly distributed, but we can also see a couple of things that are going to sort of stand out as unique pieces of content that are having the highest issues. Keyboard accessibility and focus control, for instance, is 17.5%. Document structure, just under 16. Color, and so that would be use of color or things like color contrast. That's really high. That's 15.4, and so on. So those are sort of the three highest there in our manual testing. Similar to our other pie chart from automatic testing, here's our issues by level. 75% are WCAG level A, level AA 21%, level AAA 4%. Now, there's a couple of things to keep in mind here when we're talking about this particular chart, is that this data is a little bit skewed against level AAA, because we very rarely have customers who are asking us for level AAA things. We sometimes sneak them in though. Issues by principal. This is very, very similar. This is almost identical, other than the very low score that we had for robustness before. So perceivability, still the highest, it's 36%. Operable, still the highest at 22%. with understandable and robust coming in closely behind that. Issues by severity. This is a metric that Tenon, the automatic product, does track, but we don't expose it in the data yet. But we track a different thing in the automatic tool, which is called priority, which is sort of a mix of a couple of things. Issues by severity. You can see here that the issues with high severity, 44%. Now, high severity for us, we define this as an issue bad enough that it will completely prevent a user with a disability from completing a task. It's 44% of the issues. 41% is that they could complete it with significant difficulty high enough that lots of people would quit. And 15% is low, which means they would complete the task, but they would be pretty frustrated by it. Our audit system, it's our internal system that we've created, also tracks issues by affected population. And so we can see here, pretty similar to our WCAG principles. Remember, we were talking about perceivable, operable, understandable, robust. Blind and low vision, very, very high. Cognitively impaired, very, very high. So blind and low vision together, they're about 60% of issues. Cognitively impaired, 29. Motor impaired, 12. Now, the deaf and hard of hearing and speech impaired are extremely low, but don't get confused by that, because when we do find an issue that impacts someone who's deaf and hard of hearing or speech impaired, it's a very, very high severity issue. All of those issues are going to be complete blockers for those folks. And it also just so happens that we don't test in our manual audits. We tend to not test features that are going to require speech or require hearing, because those things are usually speech input and audio, multimedia content. So those feature, the actual number of features that are out there on the customer sites is kind of low. We also track issues by platform in our tracking system. And what you can see here is over 50% of the issues that we've discovered are going to impact everyone, okay? They're going to have a universal impact regardless of what assistive technologies that the user is using. So I wanted to compare this information. As I was sort of creating these slides and gathering this data, I started noticing something pretty interesting. The top 90% of issues by content category are extremely similar. So in automatic testing, we have images and non-text content, navigation, language typography and content, custom controls, and document structure. Those are five content categories account for 90% of the issues. In manual, there's a lot more content categories that are going to account for 90%. Keyboard accessibility and focus control, document structure, color, language typography and content, role state accessibility, properties, so on and so forth. But if we look at this very close, you can see strong correlation. In this 90% is both sides have images and non-text content. Both sides have navigation. Both sides have language typography and content. Custom controls is roughly equated to role state and accessibility properties in number 5, and document structures there. In other words, the 90% of issues from automated are also going to be in manual, and so we can see here there's more things in manual, but look at that correlation. So then I decided to look at the top failing success criteria for each of these. And so this is automated. In the interest of time, I'm not going to read these out. If any visually impaired folks are on the call or on the meeting, I will have my slides shared. But I want to take a quick look at this for those of you who are viewing. 1.1.1, link purpose, info and relationships, name, state, role, and value. That's the 80-20. 80% of the issues in automatic testing are here. 80% in manual is actually 11 success criteria. So let's take a look at that. Now here's the really interesting thing. 7 of the top 10 failing success criteria are shared among automatic and manual. Non-text content, information and relationships, color contrast, resize text, link purpose, labels or instructions, name, role, and value. Wait, I thought automatic testing wasn't enough. I've said that for a decade at least. Automatic testing isn't enough. What we really know about this is that there's an extremely strong correlation between the automatically created data and the manually created data for issues by content type, issues by WCAG principle, issues by WCAG level, and the top failing success criteria. There are very few instances where our manual audits are going to find something that we've never seen before. 90% of the issues on the automated tool come from 20 tests. Like I said, we have 260 something tests on Tenon, and 90% of the issues come from 20 of them. 80% of the issues come from only 12. So what we know beyond a shadow of a doubt is that despite the claim that only 25% of accessibility best practices can be found by a tool, the automated tools are finding extreme volumes of the same exact things. All of the top 50 test failures fit into 5 meta issues: link quality, text alternatives, insufficient contrast, object labels or label quality, and table and header structure. What we know is that it really isn't esoteric and weird stuff that we find most often. What we find is it's always the same thing over and over and over again. So the code samples on this slide are the actual unit test fixtures from one of Tenon's automatic tests. And so it looks for what are, for the most part, really weird patterns on spans that have a role of image and various labeling strategies. Now, this was born from actual code that I saw in the wild while doing a manual audit, but but this particular test in Tenon that looks for an item with a role of image and a label, it's extremely rare for us to actually find a failing of this particular test. I think we're talking about sub a 0.1%. By the time, so this takes us back to our discussion of manual testing and how that works for us. As I said before, it's really, 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 really rare for us to find something that we've never found before. So there's a lot of repetition in the work for an accessibility auditor. And what we've done is we've actually gone ahead and made boilerplate issue descriptions. And the boilerplate issue descriptions during the audit process are merely enhanced with actual unique notes about what the exact problem is for the customer's instance. So this code sample, for instance, would be replaced with the actual issued code from their stuff. But the other information doesn't need to be made unique around the what we call the impact statement. By the time we've logged a handful of issues in our accessibility audit, we've already established what the issues are in a given content category. Like, we know your decorative images have bad alt attributes. We know your form fields have no labels. We know your error handling really sucks. Like, we know that very, very quickly. So how do we turn like both of these pieces of data into action? So just so you know, that this chart on this slide is not based on real data, but it's really meant to illustrate a pretty simple concept, which is why it's a very simple chart. At the beginning of a project, when we're doing auditing and stuff like that, every dollar that you spend is good money spent, right, to discover new issues. And there's going to be a point at which new issue discovery slows down. And from that moment forward, more money must be spent on each additional new discovery. So in other words, at the beginning of the project, the customer who has paid us to do this audit is spending good money. We are finding good information. On the other side of things, though, there's going to be a point at which it's kind of a waste of money to continue because we've already seen enough. That's another reason why, by the way, our manual audits only have about 23 components, is because we want to focus on unique patterns. So here's how we want to turn that data into action. We want to do our automatic testing first, okay? This is going to save money and time. And I think of this as a metric of efficiency. And you can even think of this as talking about energy efficiency in, I don't know, physics, like the amount of work done versus the amount of movement made. The estimated time to bug for an automatic tool is 0.01 seconds per issue, right? Because automatic tools are very, very, very fast. Do the automatic testing first. This is going to save people money and time. Whether you're hiring an external consultant like me or whether you have internal resources, automatic testing done first is going to save a shitload of money and time. During manual testing, learn to recognize the point at which you need to pivot from discovery of new issues to guidance. In other words, again, when I go back to this slide and we see here, we've gotten to a point where we're not discovering too much new stuff. That's the point at which we switch. And we say, okay, we know what the problems are now. Now we're going to work on fixing your problems, work on helping you understand the error patterns, helping you understand the things that you are doing that are wrong. Because usually, let's face it, as a developer myself, I always do certain things the exact same way until I learn about a way to do it better. It's always going to be the same thing. So when we reach that point at which we've gathered the necessary data to know what the problems are, then it's time for us to provide guidance to the developers on exactly what the problems are and why they are problems, and then work to provide that guidance to the developers. During the reporting phase, provide ultra clear guidance up front and expect the developers to avail themselves of that guidance. In other words, it's not good enough to merely state to the customer, your form labels are garbage, right? Or this label is unclear. You have to tell them exactly why it's a problem, and you have to tell them what to do. As a matter of fact, a good tester has the ability to do three things. First and foremost is obviously finding the problem. The second thing is being able to articulate why it's a problem. And the third thing, and this is something unfortunately a lot of testers are lacking in, is being able to articulate exactly what needs to be changed in order to avoid that problem in the future. In my opinion, and I'm saying this when 70% of my income comes from auditing is a speed bump. Auditing is a speed bump that slows the eventual resolution and reduces learning opportunities. In other words, auditing is going to fix your current problem. It is not going to fix future problems. So the thing that fixes future problems is training. So that's why, again, I focus on this opportunity to flip from discovery to guidance that we can do differently, so that we can provide education around the issues that we've discovered. So that is it for me.